when we're evaluating the pattern matching using BoyerMoore, we're going to line up the needle at the beginning of the haystack, and we're going to start from the end. So inside the haystack, we have index I, and inside the needle, we're going to have index J. Upon matching, if these two characters match, the character at I inside the haystack and the character at J inside the needle, if those match, we're going to decrement both values and compare the next two. Decrement, compare the next two if they match. If they do not match, we're going to use this equation to calculate the next index. So we're going to look at I, the index inside the haystack, plus the length of the needle minus the minimum of either J, which is the index in the needle, or 1 plus the last function. So we're going to use this table we previously generated, and we're going to plug in the character at index I inside the haystack. So if we look at this example, we can see that L does not match E. So I and J do not match. So we can plug in these values here, and if we look at 0 index, 0, 1, 2, 3, 4, 5, 6. So L is going to be, I is at index 6, plus the length of the needle, since this is 0 index, it's length 7, minus the minimum of J, which is 6, or 1 plus the last function of H. So if we look at the character at index I inside H, we see that it's L. So if we take L and we plug it into our last function here, we can see that that is index 5. So we're going to have 1 plus 5, which the minimum of 6 or 6 is going to be 6. So our new index for I is going to be 6 plus 7 minus 6. So 6 plus 1, so our new index is going to be 7. Okay. So we're going to shift I over 1 to index 7, and now we're going to line up I and J are going to be equal again. And we have to line up the last character inside the needle with I and J. So we're going to end up with so you can see here we have I and J, the characters do match. So what we're going to do is we're going to decrement both I and J. So I and J. L and L, they match again, decrement. They match again, P and P, decrement. This is J. M, they match again. They match again. It's the decrement. J, I. So now we're looking, we have S and X. S and X do not match, so we have to use this function again. So if we plug in these values, so 0, 1, 2, so I is equal to 2 plus the length of n, which is 7, minus the minimum of J is at 0, 1, or 1 plus. So the last function at I is going to be last function I. So we take S. S is the character at I inside the haystack, and we plug S into here. We see that it does not exist. It's one of the characters that's undefined, so we plug in -1. So 1 plus -1, So this turns out to be 2 plus 7 minus, and our minimum is 0 right here. So 2 plus 7 is our new index, 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we're going to line out by J. P. So we look at I and J, they do match, so decrement, J, I. Now we look space in L, do not match, so we do this equation again. And real quick, so index I is 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 7 minus minimum of J, which is going to be 6, 5, or 1 plus. So our character at in the haystack at index I is space, and if we look it up here, it does not exist. So we're going to end up with -1. So our minimum here is 0. So 8 plus 7 is 15. So if this is 8, 9, 10, 11, 12, 13, 14, 15. I, J. And if we look now, we can see that each of these match up. We know we're done when we have decremented J past index 0 and J is equal to -1. We know we're done. And I will be decremented past the beginning of the string. So the index at which we find this string is at I plus 1 after we're finished. So once J is equal to -1, then we're going to return I plus 1, and this is going to be the index at which we find our needle inside the haystack.